This is for the test review, Unit 3 projectile motion. The horizontal component of a projectile's velocity is independent, meaning they don't work together. That's what independent means. Is independent of the vertical velocity. So again, those two do not work together. What is the optimum angle to throw a projectile for maximum range? If we want it to go farther out, the best angle to do that would be 45 degrees. 45 degrees is going to give us the furthest distance out. True or false, the pathway of a projectile is called a parabolic curve. That is true. That is what the pathway is called, a parabolic curve. True or false, if a projectile is launched horizontally while a separate object is dropped from the same height of the object that is dropped, which will hit the ground first? So let me draw that out for you. We have an object going straight down, and then we have an object shooting out and going down. So that's kind of like the video from Mythbusters with the bullet going down and then the bullet being straight across. Which one hit the ground first in that video? Yes, they both hit the ground at the exact same time. So this statement is false. Because they both hit the ground at the same time. Yes, that's correct. All right, number 5. For an arrow to hit its target dead center, where must the archer aim? So remember, if we're hitting an arrow, all objects go downward. So if we know that for our target, that the arrow is going to go downward, where should you aim? Right above it. So that way, if you hit it at an angle, say 15 degrees, it'll go up, then it'll come down, and then it'll hit the target. Number 6, if a projectile is thrown upward at an angle, when would its vertical velocity be 0 meters per second? So if we throw anything up in the air and it comes back down, where is the velocity 0 meters per second? At the very top. Good job. Remember, velocity is 0 just before it comes back down. It starts to slow down as it goes up, and then it starts to gain speed as it goes back down. So at the very top, it's 0. Number 7, how do we represent gravity in a projectile motion? Hopefully everyone knows this by now. Gravity is always negative 9.8 meters per second squared. That's always the value of gravity here on Earth. On the moon, it's 1.6, but we don't need to worry about that. We're just dealing with objects on Earth. If an airplane drops a package mid-flight, where would the package be in relation to the airplane as time passes? So we're talking about the same thing, an object being thrown down and an airplane flying. So you only know this answer if you were really paying attention to that very first video we showed in our notes. If you were paying attention to that video, if you drop an object outside of something that's moving, it's going to continue forward with that same velocity. So it'll be directly under the airplane. And that's because the object that you dropped is still kind of going the same velocity as the airplane. It's like if you've ever been in a car while someone's driving and they slam on the brakes, what happens to your body when they slam on the brakes? Well, okay, let's make it PG. You don't go flying out the way. You get pulled forward. That's because technically your body is going as fast as the car. You're traveling at the same speed the car is going. So if you're going 60 miles per hour in your car, your body is also going 60 miles per hour. That object in the plane is going just as fast as that plane. So when it's released outside, it still has that forward velocity until it slows down because of air resistance. But again, without air resistance, it's just going to keep going as fast as the airplane. So number 9 is when we start getting to math. An autographed baseball rolls off of a 0.7 meters high desk and strikes the floor 0.25 meters away from the base of the desk. How fast was it rolling? So if it's 0.7 meters high, that's our vertical distance, that's our dy. If it strikes 0.25 meters away, that's our horizontal distance, dx. And we're looking for how fast it was rolling, so we're looking for our velocity. And I said before, we're always going to be looking for one specific velocity. We're always going to be looking for Vx, never Vy. And that's because initial Vy is always 0. So we're always just going to be looking for Vx. So hopefully you noticed when you were working out these problems that in order to find Vx, you need time. So this is a 2-step problem. So the first thing you're going to do is find time using your formulas. And I hope you all have your formula charts with you whenever you do take the test, or at least I hope you have them written down in your notebook. And if you don't, you are going to write them down in your notebook before the test, right? Okay. So the formula for time is time equals the square root of 2 dy over gravity. When you plug in your numbers, it's the square root of 2 times your dy was 0.7 divided by gravity, which is 9.8. 2 times 0.7 divided by just positive 9.8. Never put a negative under a square root. Don't forget that. So that would be the square root of 0.142857. And then when you square root that value, your time is 0.37796 seconds. That's not your answer. That's just the time. Now we can use time to solve for Vx in our second equation. In our second equation, Vx equals dx over t. Dx in our problem was 0.25. Time, we just solved time, that's 0.37796. When you divide those two, you get 0.66145 meters per second. Don't forget on your test, you are going to have to show your work. You're going to have to take a picture of your work and submit it just like you've been doing. So make sure you have everything clearly labeled and circled and squared for me so I can see your work. And make sure you have your name on your papers. If you don't have your name, I'm only giving you 1 point. All right, number 10, Natalie recklessly drives her car off the edge of a 203-meter tall cliff. If her speed was 45.8 meters per second, how far from the base of the cliff where her car hit? So we know the cliff is 203 meters tall, so that's our dy. because it's vertical. Her speed was 45.8 meters per second. Remember, speed's always going to be your Vx. It's never going to be the Vy. How far from the base will her car hit? So we want to know how far from the base. So that means we're looking for our dx, our horizontal distance. Again, this is going to be a two-parter. If you're looking at your formulas to solve for dx, you do need time. So first, we're going to solve for time. And we're going to use the same formula we did last time. Time equals the square root of 2 dy over gravity. You're going to plug in your numbers, the square root of 2 times 203 divided by 9.8. Remember, don't put negatives under a square root. 2 times 203 divided by 9.8. We're going to have the square root of 41.42857. And when you square root that number, your time is going to be 6.4365 seconds. Again, that's not your final answer, that's just time. So now we're going to use time to solve for dx using our dx formula. On your chart, it says that dx equals vx times t. Plug in your numbers. Your vx was 45.8. Your time was 6.4365. If you multiply those two, your dx is going to be 294.7917 meters for your distance. Number 11, Sal goes cliff diving off a tall cliff. He runs at a speed of 3.21 meters per second and lands in the water 19.7 meters from the base of the cliff. How tall is the cliff? So we know he has a speed of 3.21. That's our Vx. We're never solving for Vy. He lands in the water 19.7 meters from the base. So that means that's our dx, our horizontal. We want to know how tall the cliff is. Tall is vertical, so that's our dy. We're looking for dy. Again, this is a two-part problem. To solve for dy, you still need time. So first, we're going to solve for time using Vx and dx. Time equals our dx divided by Vx. Plugging in our numbers, dx equals 19.7. Vx equals 3.21. 19.7 divided by 3.21. Our time is 6.137 seconds. Now we're going to use our time to solve for dy with our dy formula. Dy equals gravity multiplied by time squared over 2. Remember, you're only squaring time. You're not squaring anything else, just your time. So gravity is 9.8. Time is 6.137 squared. You're only squaring time. Divide that by 2. So time squared times 9.8 divided by 2. Your dy should be 184.55681 meters. So remember, when you're taking the test, the hardest part is figuring out which numbers are what. That is the hardest part. When you're solving these problems, if you don't get the answer, make sure you figured out the right variables. Just go back and look at those to make sure you have them labeled correctly. Number 12, Arden is skydiving without a parachute. If her plane is traveling at 129 meters per second and is up at 1,200 meters when she leaps out, how far horizontally will she travel before she hits the ground? So we know she's traveling at this velocity. And again, that's going to be her Vx. She's up at 1,200 meters. Up's vertical, so that's our dy. We want to know how far horizontally she travels. So horizontally is our dx. Again, to solve for dx, we need time, so this is another two-part problem. We're going to solve time using our dy. So time equals 2 times dy over gravity. Square root of 2 times 1,200 divided by 9.8. Remember, don't put your negative. 2 times 1,200 divided by 9.8. That's the square root of 244.89796. If you square root that value, your time is 15.6492 seconds. Now we have our time. Now we can solve for dx. The formula for dx is Vx times t. Vx in our problem was 129. Time we just solved for is 15.6492. 129 times 15.6492. Our horizontal distance is 2018.7468 and meters since we're looking for our distance. Number 13. A pelican flying along a horizontal path drops a fish from a height of 7.9 meters. The fish travels 9 meters horizontally before it hits the water below. What is the pelican's initial speed? That's supposed to be P. So we know we have a height of 7.9 meters. Height's vertical, so that's our dy. 9.0 meters horizontally, that means that's our dx. And we're looking for the speed, the Vx. Another two-part problem because Vx needs time. So the first thing we're going to do, time equals the square root of 2 dy over gravity. Square root of 2 times our dy was 7.9. Divide that by gravity, 9.8. When you square root all of that, your time should have been 1.2697 seconds. Now you can use your time to find Vx. Vx equals dx over t. Dx in our problem was 9 meters. Time we solved for was 1.2697. Our final velocity was 7.088 meters per second. Number 14. A cat chases a mouse across a 3-meter high table. The mouse steps out of the way. The cat slides off the table and strikes the floor 2.9 meters from the edge of the table. What was the cat's speed when it slid off the table? So we know our table is 3.0 meters high. That's our dy, because it's going up and down. Strikes the floor 2.9 meters from the edge. That's our dx, our horizontal. We want to know the cat's speed, the vx. Again, another two-part problem. Just like the one above it, we're going to do the same exact steps. So first we're finding time using the square root of 2 dy over gravity. So the square root of 2 times dy was 3. Divide that by 9.8. 2 times 3 divided by 9.8, that's the square root of 0.61224. When you square root that value, your time is 0.78246 seconds. Now we have our time, we can solve for our velocity. Horizontal velocity equals horizontal distance over time. dx in the problem was 2.9. And we just solved for our time. 0.78246. 2.9 divided by 0.78. Our velocity is 3.706 meters per second. It's a lot of math, right, guys? A lot of math. So if you haven't noticed already, we're almost using the same 4 formulas over and over again. Those are really the 4 main formulas you need to focus on. How long will it take a shell fired horizontally from a cliff at an initial velocity of 800 meters per second to reach the ground below 150 meters? So we're looking for how long it will take. That means we're looking for our time. We know that the initial velocity is 800 because it told us so. And we want to know how long it's going to reach the ground, 150 meters below it. So that's our dy. Technically, this is only a one-step problem. You only need time, and you can find time just with dy. You don't need anything else. So all we're going to do is time equals the square root of 2 dy over gravity. So the square root of 2 times 150 divided by 9.8. 2 times 150 divided by 9.8, that's the square root of 30.61224. When you square root that value, your time should be 5.5328 seconds. And that was just the one-step problem. Number 16, what is the acceleration of a bullet that is shot horizontally? So when you're shooting a bullet, does it keep going straight forever and ever and ever and ever and ever and ever and ever? What happens to your bullet eventually? It drops. Because what's affecting the bullet in the air? Gravity, which is negative 9.8 meters per second squared. That is the acceleration. Good job, good job. Number 17, what angle will give you the same range for an object launched at 15 degrees? So I never mentioned this before, and I'm sorry. Sorry? 75, good job. So I've never mentioned this before, and I'm sorry, so I'm going to tell you now. The partner angle is going to be 90 degrees, minus whatever angle they give you. That's going to be your partner angle. So don't forget that on tomorrow's test. 90 degrees minus whatever degree they tell you is your partner angle. So if we have 90 minus 15, just like Gage said, that's going to be 75 degrees. Those two angles will give you the same horizontal distance, 15 degrees and 75 degrees. But which one will go higher, 15 or 75? The 75, right? Remember, the higher your angle, the higher your object is going to go into the air. So if you have a 90-degree angle, that's going to go the highest. Which direction are projectiles always accelerating? Which way are they always accelerating? Down. Good job. It's always down because gravity. Oh, I can't spell because. Sorry. Because gravity is negative 9.8. And that negative means it's going down. That's why whenever you shoot something up in the air, it always comes back down because gravity is pushing down on it. All right, our last two are more math problems. While skiing, Junior leaves the horizontal end of the ramp with a velocity of 12 meters per second. How far out from his starting point will Junior land if he drops a distance of 18.5 meters? So we know we got our velocity, our Vx. We want to know how far out. So we want to know the dx. And we know that he lands a distance of 18.5 meters. He drops. So that's our dy because it's going vertical. Another two-part problem. To solve for dx, you need time. So we're going to use dy first. Time equals the square root of 2 dy over gravity. Square root of 2 times our dy is 18.5. Divide that by gravity, which is 9.8. 18.5 times 2 divided by 9.8. That's the square root of 3.7755. Our time is 1.943 seconds. Now we can use time to solve for dx. Dx equals Vx times t. So you're just multiplying your velocity, which is 12, times your time that we just solved for, which is 1.943. 12 times 1.9, that gives you 23.316 meters. And our last problem. Coach Smith throws a baseball with a horizontal velocity of 25 meters per second. That's our Vx. It takes 1.2 seconds to hit the ground. That's our time. How far did David throw the ball? So we want to know how far. That's our dx. This time, it's not a two-step problem. We're looking for dx. The formula for dx equals Vx times t. We have Vx. We have t. All you have to do is multiply. 25 times 1.2. That equals 30 meters. I know on your assignment yesterday, I told you the answer was 20.8. That was wrong. I'm sorry, that was a typo. The answer is 30. So if you got 30, I did give you credit for it. And And that's it. That's your review. Good luck studying. Your test is tomorrow.